Hello friends, welcome to this second video on binomial distribution. We will see how to solve problems in binomial distributions in this video. We will have this problem to be considered as we have a large consignment of electric bulbs and 10% of them are going to be defective. A random sample of 10 of them is taken for inspection. Find the probability that all are good bulbs. Exactly 3 defective bulbs are chosen. At most 3 defective bulbs are chosen. So in this case we see that there are going to be a sample of 10 pieces that are going to be chosen for investigation. So we have n, the number of items to be investigated is going to be equal to 10, and since n, the number of items to be investigated are going to be less than 20, we choose binomial distribution for this particular problem. Binomial distribution for this particular problem. Since we have been not given any clue that what distribution to choose for or apply for, this has to be taken as a clue. N, which is going to be 10, is going to be less in number, and so the problem can best work using binomial distribution. Once we have decided we are going to use binomial distribution, the first thing is to fix your problem for your probability of binomial. So we consider the formula for the probability mass function of binomial distribution. Recollect students, probability that x takes the value x is given by ncx p power x q power n minus x, where n stands for the number of trials, your p stands for the probability of success, and q stands for the probability of failure. And we know that p plus q will always be equal to 1 since the total probability is 1. So after considering this to be binomial and n to be equal to 10, we go on to search for the second data, which says that there are going to be consignment has 10% of defective. So whenever we are going to put ourselves in the position of an inspector and then choosing a defective will be termed as a success, because we don't want the wrong items to go into market and then spoil our name. So what is going to be the probability of success? Success is going to be p is going to be 10%, and we say that what is going to be termed as success? Choosing a defective bulb. A defective bulb is going to be termed as success. So this can be now written as 10 by 100. So one of it can be cancelled off and this makes it as 0.1. So we have p to be equal to 0.1. Already we have n is equal to 10, p equal to 10, p equal to 0.1. The next thing is going to be, we need the quantity q which is appearing in the formula. Q is nothing but 1 minus of p, so it is going to be 1 minus of 0.1, so that makes it as 0.9. So q now takes the value 0.9. So now we are ready to fix the problem. So this now takes the format. This is equal to 10 cx 0.1 power x 0.9 power 10 minus x, and this represents probability that x is equal to x. So what we are choosing x, the random variable, as x is going to be the action of choosing the number of defective bulbs, in which case the probability of choosing the defective bulb is p and the probability of choosing a good bulb is going to be termed as q. Now once this formula is fixed, we are now ready to key in. Please go through the calculator tips and how to feed in your calculator with this expression, so that we will be able to use the same expression again and again and obtain the required result. The first question now asks us, all of them are good bulbs. What is the probability that all of them are going to be good bulbs? The problem has been defined for a defective bulbs. So when you want a good bulb, then what is going to be the case? So we are going to go for the probability that all of them are good, so none of them are going to be defective. So what does 0 stand for? 0 stands for no defective, no defective. So it is going to be all good, all good. So how to express this? This is nothing but equal to 10C0 0.1 to the power of 0, 0.9 to the power of 10 minus 0. So in your calculator part, for x equal to, feed in the value of 0 and press equal to, then you will get your answer to be equal to 0.3487. So fix it to 4 places of decimal so that we don't lose any data by round of error. The second question says that what is going to be the probability of choosing exactly 3 defective bulbs. So the word is exactly. So we want probability of x exactly 3 defective bulbs. So this is going to be the number of defective bulbs, number of defective bulbs. So now how to work about this? This is nothing but 10C3 0.1 to the power of 3, 0.9 to the power of 10 minus 3. So this gives me 10C3 0.1 to the power of 3, 0.9 to the power of 7. So once in your calculator you have fed the expression and then choose the value of x to be equal to 3 and press equal to, your answer gets evaluated as 0.0574. Now moving on to the last subdivision, you want at most 3 defective bulbs. So you want at most 3. So what is meant by at most? So maximum is going to be 3. So probability that maximum is going to be 3, and so you can have quantities less than or equal to 3. So now this, how to evaluate it? We know that the probability function is going to be defined for x varying from 0, 1, 2 up to n. What is going to be n? N is going to be 10. So when I going to have 3 and less than 3, what are the numbers less than 3? 3, 2, 1 and 0. So what will happen in next case? This is nothing but probability that x takes the value 0, probability x takes the value 1, probability that x takes the value 2, and probability that x takes the value 3. So now we already know the answer for x equal to 0 and x equal to 3. The only thing is that we need to get for x equal to 1 and x equal to 2. Use your calculator, calculate the values for the quantity x equal to 1, get your data, x equal to 2, get your data. Then if you are going to fix it, this is going to be 0.3487. For x equal to 1, you will have it as 0.3874. For x equal to 2, you will have it as 0.1937. X equal to 3 is already been estimated as 0.0574. When we add up all of these, the total sum will be 0.9872. So the probability of getting maximum 3 defective bulb is going to be 0.9872. So this completes all the 3 subdivisions for a binomial problem. So if you are not comfortable using your keying in a formula, please go for the individual calculation. You can find a NCR button on top of the division symbol of your calculator. Use the shift button and estimate the value for 10C0. The power button is usually given by the symbol called as caret. So this you can evaluate the whole to the power of and then key in the number and then get the required result as such. So if this is going to be the case, you are not comfortable by keying in the expression, then you can go for step-by-step estimation of the data and then complete the process in the same way.